Hello everyone, welcome to Discrete Mathematics, and you're still with me, Adila Krishnadi. And in this video series we will talk about representation of graph. Here is the acknowledgements and references, and graph representation that we will be talking about here will consist of three representations. So one is adjacency list, and then we will talk about adjacency matrix, and then incidence matrix. So let's start with the first one, adjacency list. So given a graph G, which could be directed or undirected, the adjacency list of G is simply a list L index using nodes in phi. And then given a node X, the list at the position of X will contain another list of all neighbors of X, where duplicates are allowed because node X may have a neighbor Y and they are connected by more than one edges. Now, if the graph is undirected, then Lx will contain Y if and only if Ly contains X, meaning that, well, X is a neighbor of Y and Y is a neighbor of X. Now, also if G has n loops, so you have like 1, 2, 3, 4 loops at node X, then Lx will contain n copies of X. So X will appear inside Lx itself if there is a loop, and if there is 2 loops, then X appears twice in Lx. I'm sorry. The more edges a graph has, then the longer each neighbor list tends to be. So essentially, well, if the graph is dense, meaning that every node has many edges incident at it, then we will have like very big adjacency list. So let's see some examples. So here is an adjacency, here is a graph, and what is the adjacency list of this graph? So essentially the idea is simply list the nodes. So you have A, B, C, and D. You have this is the node, and Lx, yeah, the node is X, yeah. Then Lx will contain all neighbors of that node. So essentially, so if you have A here, then the neighbor of A is A itself. There is one loop here, and then B twice, and then of course C. Well, here in this case, the order you could choose any order in this case, right? But yeah, you could choose any order with duplicates allowed. Now, how about B? B has neighbors A twice because because 2 edges are between A and B, and then we have 2 edges between B and D, so therefore D twice. How about C? C has neighbor A and then D twice, and finally D has neighbor B twice, C twice, and D once. So you see, the degree of A is actually 5, which is 3 from this and twice from A itself. Degree of B is 4. You see, this is 4. Yeah. Degree of C is 3, which you see, and then degree of D is actually 6, right? So this is 1, 2, 3, 4, and then D contributes twice, so 6, right? So that's the adjacency of this graph. How about a directed graph? So in this case, we have a directed graph with 6 nodes like this, and then the adjacency list will be like this, like as follows. So A, B, C, D, E, and F. F, then uh, the list will for A will contain all neighbors of A, that is B. Yeah, not E. Remember, E is not a neighbor of A because E is not adjacent to A. Only B is adjacent to A. How about B? B has neighbors E twice. Yeah. How about C? C has neighbors B, C, and then D. And then uh, and D will have has neighbors C. E has neighbors uh, A, and then D, and then E, and F has no neighbor, right? So nothing right here. So the length of this list, this is 1, yeah, this is 1, this is 2, 3, 1, and then 3, and then 0 is actually degree the uh, odd degree of A, yeah, odd degree of the vertex. So that's adjacency list for directed and undirected graph.